And E, rowing, is at least the least absurd of the answers. So how do we get from individual muscle cells visible in light microscopy to the visible skeletal muscles? How do we build a muscle from muscle cells or fibers and connective tissue? At each level of organization in a muscle, the unit will be surrounded by a connective tissue sleeve. Here's a fibroblast between the muscle cells, and this fibroblast is going to be secreting collagen for the wrappings at each level of organization. So we look at this cross-section of an individual muscle. The smallest structure indicated is a muscle fiber, which is also a muscle cell. And that muscle cell is surrounded by a fine connective tissue called endomysium. Muscle fascicles consist of bundles of muscle cells, and those bundles, the fascicles, are surrounded by a connective tissue perimysium. And the muscle itself, which consists of bundles of fascicles, is surrounded by a tough connective tissue endomysium. So in terms of the hierarchy, we start at the cell, surrounded by connective tissue endomysium. Bundles of muscle fibers together are surrounded by a connective tissue perimysium. The muscle itself is surrounded by an epimysium, and this is a very thick, dense connective tissue. And groups of skeletal muscles are surrounded by another layer of connective tissue. So muscle groups are surrounded by a deep fascia. As you'll see, deep fascia not only organizes the muscles in the body itself, but we can also use the groups so defined to organize our study of the muscles. The muscles in a compartment surrounded by deep fascia will have similar functions, innervation, and blood supply. In learning muscles, insofar as possible, we use logical rules and will generalize as much as we possibly can rather than memorizing very small facts. During contraction, a skeletal muscle can shorten by up to 1/3 of its resting length. The line of pull, indicated by this arrow, is the direction of force exerted by a muscle. Muscle fibers can be arranged parallel or oblique to the line of pull. So a muscle with fibers arranged parallel to the line of pull has a greater range of contraction, and a muscle with fibers arranged oblique to the line of pull has a greater force of contraction. Examples of muscles with fibers arranged parallel to the line of pull are strap muscles. So here we have an example of a very long strap muscle, a very short strap muscle, and a kind of iterated strap muscle. And this is the shape of the rectus abdominis muscle, which are the two big muscles on the anterior of your abdomen. So one exercise that you could do to demonstrate the range of a strap muscle is a sit-up. So in the morning when you jump out of the shower, you go to the mirror, you clench the muscles of your abdomen, and you see the six-pack on your anterior abdomen. That's showing you the sections of the rectus abdominis muscle. This is an example of a fusiform muscle, so this is spindle-shaped. A fusiform muscle can have a single head, can have two heads, or can have three heads. And again, because the muscles are arranged parallel to the line of pull, this muscle has a considerable range. So an example of biceps, again, would be the biceps curl, and an example of using triceps would be a triceps extension. This is an example of a pennate muscle, which means feather-shaped, and this is a bipennate muscle, which is symmetrical on both sides. One example of a bipennate muscle will be the gastrocnemius muscle, which is a big muscle in the posterior side of your thigh. If you point your toe, you're using gastrocnemius to perform that motion at the ankle. This is an example of a triangular muscle. In a triangular muscle, the fibers are arranged parallel, sort of on the shorter side, and obliquely along the hypotenuse. And if you wanted to activate a triangular muscle, you could shrug your shoulders. Notice how, when you shrug your shoulders, not only does your shoulder go up, but it kind of goes in. And so that's the action of trapezius, which the superior part at least functions like a triangular muscle. This is an example of a spiral muscle, so this is again oblique to the line of pull. And what contraction of this muscle would do would be rotate that bone in its longitudinal axis. You can pronate and supinate your forearm. Head of muscles attached to bones, always through connective tissue. So it can be a small plate of connective tissue like you can see on the top of this fusiform muscle, or through a longer tendon, which is shown at the inferior part of this fusiform muscle. Or another form of attachment is a broad sheet of connective tissue, which is called an aponeurosis. And so instead of a thinner tendon, it's a broad, flat sheet of connective tissue. Some of the anterolateral abdominal muscles, as they meet towards the center and form a sheath around rectus abdominis, will form aponeuroses. Quiz question: this muscle is an example of which of the following muscle shapes?